Hi friends, today we are going to see the problems under Z transform, that is 1 by n into n minus 1. First problem is this one, and the second problem is we have to find Z transform of 2n plus 3 divided by n plus 1 into n plus 2. This is very important problem. Denominator is having two terms. That is product of two terms in the denominator. You have to go for partial fraction method and then you have to apply the Z transform. Now we will do the first problem. Z transform of 1 by n into n minus 1. Before applying Z transform, as first you have to consider this function alone and split into partial fraction. Okay, so a by n plus b by n minus 1, and then here you have to denominator write as it is 1 by n into n minus 1, and here the same denominator n into n minus 1 you have to write. Compare these two. Here n is present and n minus 1 is not there here, so you have to multiply this by n minus 1 into a, plus compare these two terms. Here n is missing, so n into b you have to write it, and these two terms get cancelled, so you have 1 is equal to n minus 1 into a plus n into b. Okay, and here we have to find out the values of a and b. When you finding a and b, you have to give the values for n. When you substituting n is equal to 0 here, this term becomes 0 and you get the value of a easily. Okay, so put n is equal to 0, then 1 is equal to n is equal to 0 here. 0 minus 1 you have minus 1 into a, plus this term becomes 0, or a is equal to minus 1. Okay, when you're substituting n is equal to 1 here, that n is equal to 1 here, 1 minus 1 it becomes 0, so a becomes 0, you get the value of b. So when you're substituting n is equal to 1, 1 is equal to this term becomes 0 plus 1 into b, or the value of b is equal to 1. Now we have to substitute these values a and b in this equation. Number this equation as 1. So substituting a and b in 1. Okay, a and b values in the equation 1, we get 1 by n into n minus 1 is equal to the value of a is equal to minus 1 by n plus the value of b is equal to 1 by n minus 1. Or you can write this to be minus term, positive term first and negative term to be second. 1 by n minus 1 minus 1 by n. Okay, next we have to find out Z transform of this function. Okay, so apply Z transform on both sides. Z transform of 1 by n into n minus 1 is equal to Z transform of 1 by n minus 1 minus 1 by n. Since Z transform is linear, you can take Z transform inside these brackets or each and every terms. So we have to find out Z transform of this function. Apply the definition of Z transform. N is equal to 0 to infinity. 1 by n minus 1 is Z power minus n minus 1 by n. You have to apply Z transform of 1 by n. Also you have to apply. What is the transform of 1 by n? As usual, you have to apply the definition. N is equal to 0 to infinity. 1 by n is Z power minus n. If you know the value of Z transform of 1 by n, you can write it directly. Otherwise, you have to use the definition. I'll show how to do using the definition in this problem. Okay, now which is equal to, when you're substituting n is equal to 0 here, this becomes negative. Okay, and when you're substituting n is equal to 1 here, 1 by 1 minus 1 it becomes 0. This series is divergent. Okay, so when you're substituting n is equal to 2, it is only positive value because it is a casual sequence we are taking. That's why. Okay, we are omitting the negative terms, and the when you're substituting n is equal to 0, this becomes negative. Since the function we are taking a sequence as a casual sequence, so it cannot take the negative values. That's why we omit n is equal to 0 also. And when you're substituting n is equal to 1 here, this term becomes 1 by 0. 1 by 0 is infinity. This series becomes divergent, so you have to leave n is equal to 1 also. So n varies from 2 to infinity. Only you have to consider here z power minus n. Minus summation. Here when you're substituting n is equal to 0, again see this is divergent, so you have to omit n is equal to 0 here. Start from n is equal to 1 to infinity. Now substitute n is equal to 1 here. Okay, when you substitute n is equal to 2, 1 by 2 minus 1 is 1 into z power minus 2 plus n is equal to 3 is substituted. 1 by 3 minus 1 is 2 into z power minus 3 plus n is equal to 4 is substituted. 1 by 4 minus 1 is 3 into z power minus 4 plus etc. This is your first summation. Minus this term you have to write it. Here when you substituting n is equal to 1, you have 1 into z power minus 1 plus n is substituting n is equal to 2. 1 by 2 into z power minus 2 plus n is equal to 3 is substituted. 1 by 3 into z power minus 3 plus etc. Or you can write this to be 1 by z squared plus 1 by 2 into 1 by z cube plus 1 by 3 into 1 by z power 4 plus etc. You have minus the second summation is 1 by z plus 1 by 2 into 1 by z squared plus 1 by 3 into 1 by z cube plus etc. Okay. And what about this summation here? Here 1 by z is there and 2 is there, z squared, 3 z cube, 1 by 4 z power 4, like that this series is having. So this value is minus, you know that, isn't it? Minus log of 1 minus 1 by z. What about log x? That is x plus x by 2 plus x squared by x squared by 2 plus x cubed by 3 plus etc. is equal to minus log of 1 minus x. This is a series we know. Here x is equal to 1 by z we are applying. So this you can replace. This series can be replaced like this. And what about this one? The second series. What about this one? Here z squared is there and there is constant is not present, and 2 is there, and here z cube is there. But according to when we are applying to a log function, you have to here 2 na z power 2 is also power is z power is also 2. Here number 3 z power is 3, like that it have. But here 2 is there but 3 is there, z power 4 is there. So you have to make these terms to be same. So for how will it possible? When you taking 1 by z, this becomes z squared and this becomes z cube, and here also 3. So we have to take 1 by z outside. Okay. When you are substituting 1 by z outside, remaining you have 1 by z plus 1 by 2 into 1 by z square, because 1 by z is taken outside, plus 1 by 3 into 1 by z cube plus etc. Okay, minus, and you know that this term can be written as minus log of, this term is minus log of 1 minus 1 by z. Okay, this is the expansion for this. And what about this term 1 by z into, again you can write this to be minus log of 1 minus 1 by z. Okay, and this minus it becomes plus log of 1 minus 1 by z. Or you can write this to be 1 by z into minus log of z minus 1 by z. Okay, plus log of z minus 1 by z. This is the answer we have, and you have to simplify these two terms further. So you have to simplify this, which is equal to, here you take the negative terms first and positive terms next. Okay, so you can write this to be here log of 1 by log of z minus 1 by z. No need to further simplify both the terms having z minus 1 here. Okay. So z minus 1 minus 1 by z into log of z minus 1 by z. Okay. Now we have to take a log of z minus 1 by z is common. Take it outside. Log of z minus 1 by z is taken outside. Remaining you have 1 minus 1 by z. Or you can have, when you're taking LCM for this, log of z minus 1 by z into taking LCM you have z minus 1 by z. Or you can write this to be z minus 1 by z into log of z minus 1 by z. This is the z transform of 1 by n into n minus 1 formula. Okay, and next we have to find the next problem. This is your answer. And next we have to find out, the next problem is a transform of 2n plus 3 divided by n plus 1 into n plus 2, isn't it? N plus 1 into n plus 2. Here also the denominator is product of two terms. So you have to consider this function alone. 2n plus 3 divided by n plus 1 into n plus 2. Okay, and you have to split into partial fractions, that is a by n plus 1 plus b by n plus 2. Okay, and here as usual the denominator is same. So 2n plus 3 divided by n plus 1 into n plus 2 is equal to the same denominator you have n plus 1 into n plus 2 here, and compare these two terms. N plus 1 is there and n plus 2 is missing. So n plus 2 into a plus, when you're comparing these two terms, n plus 1 is missing. So n plus 1 into b. And here these two denominators get cancelled. So you have a 2n plus 3 is equal to n plus 2 into a plus n plus 1 into b. And we have to find out the values of a and b. When you're substituting n is equal to minus 1 here, n is equal to minus 1, this term becomes 0. You can easily get the value of a. So substitute n is equal to minus 1 here, here and here. Okay. So 2 into minus 1 plus 3 is equal to, n is equal to minus 1 is substituted, plus 2 into a, and this term becomes 0. Or you have minus 2 plus 3. What is the value? 1. Minus 2 plus 3 is 1. And minus 1 plus 2 is 1. So the value of a is equal to 1. And in the same way, we have to substitute n is equal to minus 2 here. And when you're substituting n is equal to minus 2, this becomes 0 and you can get the value of b easily. So n is equal to minus 2. Suppose you're substituting n is equal to 0 here, then you get both a and b values and you have to solve it. Or here when you're substituting n is equal to 0, you can know the value, the value of a, no? So substituting that also you can find it out. But it is the easiest way. N is equal to minus 2 when you're substituting. Here you have 2 into minus 2 plus 3 is equal to, here n is equal to minus 2 is substituted. This term becomes 0. And here you have minus 2 plus 1. I'll write it here. N is equal to minus 2 is substituted. So 2 into minus 2 plus 3 is equal to, a becomes 0 and minus 2 plus 1 into b. Or you have minus 4 plus 3 is minus 1 is equal to minus b, or b is equal to 1. Now we have to substitute the values of a and b in this equation. Okay, this equation number this as 1. So substituting a and b in 1. Substituting a and b in 1, we have, problem is 2n plus 3, isn't it? 2n plus 3 divided by n plus 1 into n plus 2 is equal to, a is 1 by n plus 1 plus b is 1 by v is also equal to 1 by n plus 2. Now we have to apply Z transform on both sides. Z transform of 2n plus 3 divided by n plus 1 into n plus 2 is equal to Z transform of 1 by n plus 1 plus 1 by n plus 2. Okay, so we had to write since Z transform is linear, you have to take Z transform inside plus Z transform of 1 by n plus 2. Okay, and next we have to apply the definition here. Definition of Z transform: summation n is equal to 0 to infinity. Function is 1 by n plus 1 into Z power minus n, and the definition you have, plus summation n is equal to 0 to infinity. This is the function 1 by n plus 2 into Z power minus n. We have to write it here. Here when you substituting n is equal to 0, you have a positive term and there is no infinity. And here when you substituting n is equal to 0, we have positive term and there is no infinity here. Okay, so we take summation as usual. N is equal to 0 when you substituting 1 by 1 into Z power 0. So it becomes 1, isn't it? So 1 plus. You can write this to be 1 plus. Not 1 by 1 into n power 0, 1. Okay. And when you substituting n is equal to 1 here, 1 by 1 plus 1 is 2 into Z power minus 1. Plus when you substituting n is equal to 2, 1 by 2 plus 1 is 3 into Z power minus 2. When you substituting n is equal to 3, 1 by 3 plus 1 is 4 into Z power minus 3 plus etc. Like that it goes. Okay. And plus next summation is n is equal to 0 is substituted. So 1 by 2 into Z power 0 plus n is equal to 1 is substituted. 1 by 1 plus 2 is equal to 3 into Z power minus 1 plus 1 by n is equal to 2 is substituted. 2 plus 2 is 4 Z power minus 2 plus 1 by n is equal to 3 is substituted. 3 plus 2 is 5 into Z power minus 3 plus etc. It will go. So first term here you have Z power 0 is 1 and you have to take this 1 plus 1 by 2 into 1 by Z plus 1 by 3 into 1 by Z squared plus 1 by 4 into 1 by Z cube plus etc. Plus this term is 1 by 2 plus 1 by 3 into 1 by Z plus 1 by 4 into 1 by Z squared plus 1 by 5 into 1 by Z cube plus etc. Okay. And what about this term? Here 2 is there, but Z squared, we must have Z squared term. Then only we can apply this formula. X plus x squared by 2 plus x cube by 3 plus etc. is equal to minus log of 1 minus x. Here we have 2 and power 2. 3 power 3. Like that only we can apply this formula. But here 2 is there and here 1 is there. How will you make this to be 2? You have to multiply and divide by 1 Z. Okay, and division Z comes under this term and multiplication Z you keep it here. So 1 by Z is taken here. 1 by Z plus 1 by 2 into 1 by Z is taken inside. So 1 by Z into 1 by Z you have 1 by Z squared plus 1 by 3 into 1 by Z squared into 1 by Z cube plus 1 by 4 into 1 by Z into 1 by Z cube is 1 by Z power 4 plus etc. Okay. And in the same way, plus this term also we have to make here. 2 is there, we need Z squared, 1 by Z squared, and 3 is there, Z cube. Now we need 1 by Z squared, and it becomes Z cube. So we have to multiply and divide by 1 by 1 Z squared. Multiply and divide by Z squared, and this 1 by Z squared is taken inside. Okay, so 1 by 2 into 1 by Z squared. Now the power becomes same. Plus 1 by 3 into 1 by Z squared into Z you have Z cube 1 by 4 into z squared into z squared, it becomes z power 4 plus etc. Okay, and then z into this term can be written as, that is, this is of the form x plus 1 by x squared by 2 like this, isn't it? So minus log of 1 minus x here is 1 by z. Okay, and plus z squared into, here in order to apply this formula we need 1 by z, isn't it? 1 by z is missing here. Compare these two summations here. So 1 by z is missing. Without changing the value, we have to add and subtract 1 by z, then this value will not be changed, and we had to include this formula here. We had to take this formula, this summation. Okay, we had to take this summation as was 1 by z, plus you have to take it here 1 by z plus this term, and here you have minus 1 by z is separately there. So this term can be taken as this redlined term can be taken as minus log of 1 minus 1 by z, isn't it? And 1 minus 1 by z is left out, so you have to write this minus 1 by z here, and this z squared is common for these two terms. Now this becomes minus z into log of z minus 1 by z. You can write like this, plus z squared into, or you can take this minus outside, so it becomes minus. Okay, minus outside, so minus here you have minuses there now, so or you can take this way also. Instead of this, you can take this way also, or you write this minus z into log of z minus 1 by z, and here plus z squared into minus log of z minus 1 by z minus 1 by z. Minus 1 by z you have to take it. And this z squared is common for these two terms. You take this minus term here, so z into log of z minus 1 by z the whole inverse plus z squared into log of z minus 1 by z the whole inverse. This minus is taken here because it is a log function. Minus 1 by z you have to write it, and this z squared is common for these two terms. This is equal to z into log of z by z minus 1 you can take, isn't it? Plus reciprocal, when you're taking reciprocal, this negative becomes plus, and z squared is taken inside, z squared into log of z by z minus 1 you can take it, and this z squared comes here minus z squared by z. Okay, now this is equal to here, which is common, this term is common, log of z by z minus 1, and here log of z by z minus 1 is common, so we take it outside. And here when you're taking this outside, log of z by z minus 1 is common, and left out term is z plus z squared. So you write it here, z plus z squared into log of this term minus this get cancelled, so z. Okay, so this is the value we have, z squared plus 1. Or you can write this term to be, this z squared can be written as z into z plus 1 log of z by z minus 1 minus z. This is our z transform of 2n plus 3 divided by n plus 1 into n plus 2. This is our answer. That's all for this video. If you have any doubts or any other problems you want me to do it, please provide in the comment section. Thanks for your time and thanks for watching. Thank you.